is defined from x1 and x2, between x1 and x2 in S1. And event B, for example, between y1 and y2 on S2. Then the combined event, which is, we can call it C. C will have the elements of the set A product with the set B, which is the ordered pair, where the first element in every pair comes from A, the second element comes from B. And here will be, you can see in the square, this will be the event C. Okay, so A product B or C will be basically the elements in A from S1, S2 intersect with the elements in B in S1. سؤال يا شباب. So basically the combined experiments, think about it as a bigger experiment. لكن outcomes, every time you don't watch one outcome, you don't expect one outcome. Every time you run the experiment, you don't expect that you get a voltage. No, you get a voltage and a current مثلا. Okay, temperature and the pressure, wind speed and مثلا. So you get things of that sort. So basically, combined experiments, you don't see every time you run this combined experiment, you don't see one outcome, you see a pair or more than two pair of outcomes. Like here, hidden number of the die and so on.
Doctor, is there a probability that like a combined experiment with two independent events, such as this example, is there another example that they are dependent to each other?
They are dependent?
No, I'm asking if there's going to be.
طبعا يعني مثلا الان the weather forecast, usually the temperature or the pressure or wind speed, they are related to each other. يعني temperature in the weather in the atmosphere is highly related or correlated with the pressure. تمام، لما الويند تزيد التمبريتشر تنقص وهكذا. So this is a typical example of related sub-experiments. Okay?
Okay, thank you.
طيب, other questions? We'll go through some examples, of course. However, the concept is very important that you understand what does a combined experiment mean. Simply, it's a combination of several experiments such that the outcome, every time you run the combined experiment, the outcome is not only one outcome, it's an ordered basically pair or more than pair also, if it is more than if it is more than two experiments. Okay. So for example here, the three independent experiments can be defined by the combined probability space زي ما قلنا. هذا الاكستنشن للكلام اللي تكلمنا فيه. طبعا if they are independent experiments, then the probability of these events A1 product A2 product A3 or A1 intersect, same as intersect A2 intersect A3, will be the product of the probability of A1 multiplied by probability of A2 multiplied by probability of A3. These are if they are independent. If the experiments are not independent, you cannot say that the probability of sub-events equal the product of the individual probability. Yeah, for example here, tossing a coin and rolling a die. And I can ask you, what is the probability of C, okay, which is, for example, a head and 2. You can say clearly that the probability of C here, if C مثلا, the probability of C will be what? شباب? It's the probability of head multiplied by probability of 2 لأنه ما نعرف بعض. The outcome of the coin has nothing to do with the number coming out of the die, صح ولا لا؟
Yes, doctor.
ممتاز. فإذا كانوا independent, if independent, this can happen. This is if independent. experiments. If the experiments are not independent, then you cannot do this. In this case, basically, it's half multiplied by
1
1
over
over 6,
6.
which is 1 over 12.
1 over 12.
Excellent. طيب الآن this takes us to the counting principles, mainly the permutation and combination, because in many cases when we come to combined experiments, you need to count how many times an event happens. And because of that, we need to understand the concept of permutation or combination. طبعا most of you, I think you have taken it somewhere in before that, اللي هي التوافيق والتباديل ولا ما ادري ايش يسموها بالعربي. So, and because of that, because they are related to this concept of combined experiments, we need to discuss them here. And these are related to counting principles, we call them. Counting principles. طيب. The permutation is the number of possible sequences, okay, with the order being important. طبعا هنا without replacement. كل الاثنين هم ذول permutation والcombination without replacement. We'll give example in a minute. So the permutation of n, we call it as n permutation r, or we permute r among n. مثلا سؤال ممكن يكون related to give me the I have here one question. I have here the example. For example, we have the S, which is A, B, C, D, and E. Okay, and I can ask you how many times you can order A. You can pick 3 out of these 5 letters, where order is not important. Okay, or let me say it the other way around. How many times we can pick 3 letters out of these 5 letters, A, B, C, D, E? Okay, in this case, you can tell me that you can pick, like in the figure here, A, B, C. You can pick A, B, and D, A, B, and E, A, C, and D, and so on, right? You can pick any 3 letters. So the number of combinations of 3 letters out of 5 letters is equal كم يا شباب؟
10.
10.
10 ها؟ كيف حصلنا 10? It's n factorial, which is in this case 5. So C 5 3. It's 5 factorial divided by 3 factorial multiplied by n minus r factorial, which is 2 factorial. Okay, 5 factorial is basically 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. 3 factorial is 3 multiplied by 2 multiplied by 1. And 2 factorial is 2 multiplied by 1, right? وأنا بس بذكركم في الفactorials. So you can see that 5 factorial is basically the first. These are basically 3 factorial, which is goes with this. And you end up with 5 by 4, which is 20, yes, divided by 2, which is 10. Excellent. So there are 10 different ways you can pick 5 letters out of, sorry, 3 letters out of 5 letters. And we call this as 5 choose 3. These are the combinations, the number of combinations. Now suppose that I am interested in how many times I can pick 3 letters out of the 5 letters being ordered. Means that I count all the different permutations of the first one, A, B, C. Okay, I can have them as, I can have all the different orders, A, B, C, B, C, A, C, A, B, C, B, A, B, A, C, and A, C, B. Right? The same thing for the second combination. I can have another 6 times of being able to order them, reorder them, A, B, D, D, B, A, B, D, A, and so on. These are called permutations لأنك أنت you permute them يتغير الأوردر حقهم تمسك واحد وتوديه مكان الثاني and so on. تمام؟ The same thing for the third three letters. You can have 6 times of permutations and so on. So the number of permutations تعطيك هذه إيش اللي هي the number of combinations while every combination can be reordered. So in this case you have the number of combinations P53 equals the number of combinations which is C53 multiplied by what? 3 factorial, which is the number of permutations. So every combination can be repermuted in 6 different ways, which gives you basically الرول هذا اللي هو PNR هنا, which is the number of, it's basically n factorial divided by n minus r factorial, because we multiplied by r factorial disappears. While n choose r, you have r factorial in the denominator. Okay. شباب واضحة؟
I have a question. Can you repeat on how did we get 3 factorial? The last line.
How did we eliminate the 3 factorial?
Yeah.
Yeah. The number of combinations, for example, in this example, 5 choose 3, you can see that there are 10 combinations. How did we find 10? It's 5 factorial, n factorial, divided by r factorial, multiplied by n minus r factorial, which is in this case 5 factorial divided by 3 factorial by 2 factorial. Okay? Now, this is the number of combinations. The number of permutations are the same as the number of combination, لكن multiplied by 3 factorial. You can see that in this table, every combination here can be reordered using 6, which is 3 factorial, different ways. Okay? So every combination of these can be reordered, permuted, using 6, which is 3 factorial, different ways. And because of that, the number of permutations equals the number of combinations multiplied by 3 factorial, or multiplied by r factorial. And because of that, in the rule here, you don't see r factorial in the denominator, because you multiplied the combinations by it.
But let's suppose that instead of 6, we have a 12. It will be 4 factorial, right?
Instead of 6 خلينا نقول number of permutations 6 بدل 6 12.
Yes.
يعني you are referring to C choosing 4 out of 5. يعني بدل 3 يكون 4 هنا. A, B, C, and D. In this case, you have 12.
Right.
You have 12 of these.
So it will be 4 factorial instead of 3. We just take the numbers and to put them in a factorial and multiply them by C.
يعني الآن خلينا نقول هنا number of خلينا نقول ناخذ المثال هذا اللي هي 5 choose 4 which is C 5 4 right. هذا عبارة عن ايش 5 factorial divided by 4 factorial which is and multiplied by 1 factorial which is how much يا شباب how many what is the answer 5 factorial عبارة عن 5 multiplied by 4 factorial 4 factorial يكنسل 4 factorial يطلع لك 5 تمام
تمام.
الآن every one of these can be reordered by how many times 12 times right which is 3 which is 4 factorial. So the number of permutations equals 5 factorial divided by what 1 factorial right which is اللي هو عبارة عن C54 multiplied by 4 factorial صح؟ تمام which is equal to كم 5 factorial عبارة عن كم
5 times
2 في 3 6 في 4 24 96 صح؟
120
120 sorry. I missed one. So this is the number of combinations permutations. طيب سؤالك واضح الآن؟
Yes.
ممتاز. Other questions شباب about this concept of permutation and combination.
يس دكتور.
تفضل.
دكتور احس عندي لبس الحين الار تقصد فيها الكومبينيشن عدد الاليمنتس في الكومبينيشن اللي عندي والان المجموع الكامل حقه ولا ايش تقصد في الار؟
ايه ان هو المجموع الرقم الأصلي. يعني مثلا choosing 5 out of 7 5 students out of 7 أنا عندي طلاب 7 طلاب أبغى أختار منهم 4 ولا 5. N will be the total number of students. R will be the number of students I'm selecting. اللي هي 4 أو 5 في المثال هذا.
طيب الحين يا دكتور عندي البرميتيشن والكومبينيشن قدامها كل واحد له قانون. الحين السي ايش علاقته بالاثنين اللي فوق؟
السي
ايوه
اللي هو سي ان 3.
اي عندك البرميتيشن الحين فيه بي ار ان هذا القانون اللي فوق والكومبينيشن قدامها بعد قانون
اللي هو سي ان ار او ان تشوز ار. تمام.
ايوه ايش علاقتها كلها بس؟
علاقتها في بعض ولا علاقتها في ايش؟
الحين اللي فوق القانون اللي هذا
ايوه القانون حق البرميتيشن والقانون حق الكومبينيشن. سؤالك معليش علاقتهم في بعض ولا ايش السؤال؟
لا الحين فهمنا البرميتيشن القانون حقه ان فاكتوريال ان ناقص ار فاكتوريال صح؟
divided by n ناقص r فاكتوريال. يس.
ايوه والكومبينيشن القانون حقه اللي هو ار فاكتوريال صح؟
لا هذا القانون n فاكتوريال divided by r فاكتوريال في الدينومينيتور multiplied by n minus r فاكتوريال.
تمام.
ال r فاكتوريال يا شيخ هي for every combination how many times I permute I can permute كم ممكن أغير الترتيب حق one combination. تمام. يعني هي عشان كذا هي ما تسمع يعني أنا I don't want you just to remember القوانين. You need to understand من وين طلعناها. ال number of permutations equals the number of combinations multiplied by how many times every combination every pair ولا every sequence can be reordered. يعني أنا هنا عندي ال 5 choose 4 المثال اللي تحت هذا أنا عندي only 5 combinations. أوكي لأني أقدر كم مرة ممكن أختار 4 من 5 5 مرات. لكن كم مرة I can reorder every one of them اللي هي r factorial هو 4 factorial which is 24 times. So the number of permutations طلع 120. واضحة الفكرة هنا؟ لأنه every one of these 5 combinations I can reorder them 24 times.
يعطيك العافية.
حياك الله. فهي الآن خلينا نقول في الأسئلة أو في الحياة لما يطلع لك هي الفكرة when do you use permutation when do you use combination. أول شيء both of them when there is no replacement when you pick and you don't replace. هذا إذا كان في picking and replacement or not replacement. لأنه كل مرة when you pick and you don't replace you are reducing the number of elements that you are picking from which is the permutations. الآن you ask yourself is order important or not? If order is important then you apply permutation. If order is not important يعني زي selecting 5 students out of 7 ما تفرق أنا وين أحط أول واحد وين أحط الثاني. لكن مثلا I have خلينا نقول 5 students I want to select out of them 3 students وأبغى أرتبهم في طابور. In this case they have to be permutations. لكن إذا ما في ترتيب في الطابور only picking 3 students out of 5 it is combination because order is not important. أهم شيء الأسماء عبد الله ومحمد ومحمود. لكن إذا قلت لك لا أبغى والله عبد الله ومحمد ومحمود أحطهم في طابور كم مرة ممكن أرتبهم في الطابور؟ أوكي ساعتها you multiply by 3 factorial. واضحة الفكرة؟
Yes very clear thank you.
طيب شباب أي شيء مو واضح؟ Others. Let's take some examples. معلش نرجع للكاردز مرة ثانية. الشباب اللي ما يعرفوا الشدة شوي يعني اصبروا معنا. طيب drawing a four cards out of 52 cards. الآن لو أسألك أنا without permutations without with replacement, then the answer is none, right?
Yes.
It's 52 to the power 4 صح؟ 52 multiplied by 52 multiplied by 52 يعني لو أسألك الآن كم مرة ممكن أختار ممكن أسحب 4 كروت من 52 كارت. It's 52 times in the first drawer multiplied by 52 multiplied by 52 multiplied by 52 4 مرات 52 to the power 4. بينما if I ask you how many times I can draw 4 cards out of 52 cards without replacement, يعني كل مرة أسحب كارت ما أرجعه. In this case, this is the permutations, which is 52 factorial divided by 52 minus 4 لأنه كل مرة أسحب كارت ما أرجعه. فيصير أول مرة 52 عندي number of cards I can pick from 52. المرة الثانية كم يبقى لي كارت؟ 51 right؟ لأني سحبته ما رجعته without replacement. المرة الثالثة 50 cards. المرة الرابعة 49. So this is without replacement or picking cards without replacement. لو قلنا with replacement picking cards with replacement, then what is the answer شباب? It's 52
to the power 4.
to the power 4. Number of ways. بينما picking cards without replacement number of ways اللي هو أول مرة 52 ثاني مرة 51 and so on. الآن why is it important? Why do we do counting principles? يعني إحنا why did we do this? Because if I ask you what is the probability of picking 4 cards out of 52 cards with replacement كم الأنسر يا شباب يطلع؟ هذا هنا number of ways. طب if I ask you what is the probability of picking 4 cards out of 52 with replacement إيش رأيكم؟
We will take card each time, so it's 52, then 51.
هذه number of ways. الآن I'm asking you what is the probability of picking 4 specific cards out of 52.
Oh.
4
One
over 52.
It's 1 over this. It's 1 over the number of ways. يعني احنا why do we do counting؟ لأنه counting تعطيك كل شوف الفكرة كالتالي. When I have rolling a die, I define S clearly وأقدر أطلع الإيفنتس وأقدر أطلع كل إيفنت كم البروبابيلتي حقته and so on. أوكي؟ لما يكون الS small يعني like here 1 2 3 4 5 6 I can define any event and I can solve it. Like when I have combined experiments and I have large number of sets that I have to deal with, I need to go to what we call counting principles اللي هي permutations with combinations. عشان to find the probabilities. فالآن the probability of picking 4 random cards out of 52 cards with replacement equals 1 over 52 to the power 4. ليش؟ لأنه picking 1 card out of 52 كم ال probability؟ 1 over 52 right؟ شباب are you following ولا لا؟
Victor, you mean the same card,
Yeah.
right?
إيه the same card.
Okay.
يعني خلينا نقول هنا الكاردز are not يعني I'm not distinguishing the card اللي هو king ولا أي شيء. Picking only random cards. If I specify which card البروبابيلتي تتغير. إذا قلنا king مثلا لأنه عندنا 4 kings out of 52. No, I'm picking only 4 random cards. Whatever the card is ما تفرق. كل مرة I pick a card the probability to get a specific card is 1 over 52 صح ولا لا؟
Yes.
Yes.
So if I
Yes.
pick 4 cards with replacement كل مرة أرجع الكارد مكانه. What is the probability? It's 1 over 52 to the power 4. Right?
Yes.
Yes.
تمام. الآن if I ask you the same question, not how many times, what is the probability of picking 4 cards out of 52 without replacement? كل مرة ما أرجع الكارد مكانه. أول مرة the probability is 1 over 52, right? The second time is what? Multiplied by 1 over
1 over
51.
51.
Multiplied by third time 1 over 50
50.
اللي هي باقي الكروت. Multiplied the fourth time 1 over 49, right?
49.
ممتاز. فthe number of permutations هذه ساعدتني بإيش؟ Finding the probability of picking 4 cards without replacement. ونفس الشيء هنا لما تكلمنا with replacement. So I'm not counting just for the fun of it. I am counting. We are teaching the counting principles هنا ليش؟ Because they are useful when you have large sample spaces. ما تقدر تكتبها كذا مثل rolling a die وتجلس تعد. You have to use smart counting principles. It's very important شباب you understand why do we learn these things. لأنه this will be your way to solve problems that are related to probabilities in such settings. طيب. Another example, a coach has 5 athletes and he wants to make a team made of 3. How many teams he can make? ايش رايكم؟ 5 choose 3. ليش؟ لأنه الأوردر أنا اخترت محمد وعبد الله ومحمود. خلاص ما يحتاج أرتبهم محمود وعبد الله ومحمد. عبد الله ومحمد ومحمود ما يحتاج. So because of that we use what combinations here اللي هي 5 choose 3 which is 5 factorial divided by 2 factorial divided by 3 factorial which is 10, which is the same as choosing 2 spare teams. So basically 5 choose 3 equals 5 choose 2 by the way. يعني أنا picking 3 as a team is the same as picking 2 as a spare team. صح ولا لا؟ اللي هو المتوقعين.
Yes.
And because of that we have here 5 n choose r equals n choose n minus r. الآن if I ask you the same question, a coach has 5 athletes and he wants to make a team made of 3 where he wants to give every one of them a specific position. واحد هجوم واحد دفاع واحد حارس. Okay? In this case how many times he can make such a team?
60.
ليش؟
60.
permutation.
إيه لأنه كل مرة عبد الله ومحمد ومحمود كل واحدة فيهم هذه ممكن أخلي عبد الله هو الحارس ومحمد هو الدفاع ومحمود هو الهجوم، أو عبد الله هو الهجوم ومحمد هو الدفاع ومحمود هو الحارس and so on. I have 6 of these. So for every combination عبد الله ومحمد ومحمود I have 6 times I can reorder them أحطهم دفاع وهجوم وحارس 6 different ways. Because of that the number of permutations in this case will be 60 not 10. It's 10 multiplied by 3 factorial. واضحة الفكرة بين when do I use combination and when do I use permutation? Combination when order is not important. Permutation when order matters is important. زي لما قلنا حارس ودفاع وهجوم ساعتها تفرق. لا والله عبد الله كذا ولا كذا ولا كذا. طيب الآن إيش رأيكم العلاقة بين P n choose n r و P n r n minus r؟ هل هم equal؟
No.
No طبعا ما لهم علاقة، تماما ما لهم علاقة. البرميوتيشنز ما له علاقه، لانه كل ما يزيد الار number of permutations تزيد. تمام. طيب there's something that yeah في الباينوميال expansion هذه مهمة، يعني you know it from your maybe Taylor series ولا غيرها في الماث. binomial expansion لما يكون عندي x plus y to the power n, you know the binomial expansion, right? It's summation of r equals 0 to n choose r, x to the power r, y to the power n minus r. So this is another example where we use combination. بس يعني just for your information. طيب السؤال، أي سؤال؟ You know where do I always say why do we teach counting principles, permutation, combination, and so on? Because they help us find the number of ways of an event that can happen, which help me to find its probability. هذا هو main motivation. The second, do you know the difference and where to use permutation and combination? Both of them are used when we ask the question without replacement. Permutation is when order is not important, when order is important. Combinations when order is not important. ما تفرق أحد عبد الله حارس ولا عبد الله دفاع. Any question يا شباب؟ طيب Bernoulli trials. Bernoulli is a scientist who basically defined what we call later, we'll call later Bernoulli random variable. They are based on, or Bernoulli random variable or whatever, it's based on what we call Bernoulli trial. Bernoulli trial is a simple experiment that has only two possible outcomes. مثل head or tail. Tossing a coin, head or tail. هذه يسموها Bernoulli trial. Now, a Bernoulli trial has two possible outcomes only, A or A complement. يا يحصل يا ما يحصل. يا شيء يحصل يا عكسه يحصل. يا تنجح يا ترسب. يا نطلع يا ما نطلع. مثلا يا أبيض يا أسود. إذا مثلا خلينا نتكلم على الليل والنهار and so on. تمام؟ So a Bernoulli trial has two outcomes only. Either something happens or its opposite, اللي هو الcomplement. The probability of A, اللي هو one of the outcomes, equals P, while the probability of its complement, A complement, equals 1 minus P. So عندنا a simple experiment that has two possible outcomes. One of them happens with the probability of P, the second happens with the probability of 1 minus P. Okay. Now a Bernoulli trial, so this is a Bernoulli trial repeats this n times. يعني عندي the same experiment, I repeat it n times. This is what we call Bernoulli trial. وزي ما قلنا يطلع منها حاجة اسمها Bernoulli random variable later when we talk about it. So فاهمين experiment الآن? It has two simple outcomes. A or its complement. A happens with the probability of P. A complement happens with the probability of 1 minus P. I repeat this n times and I ask the question, what is the probability that A occurs exactly k times out of n? Okay? It's equal to, out of n, how many k times A can happen? It's n choose k. It's number of combinations. ما تفرق. أنا ما قلت لك أول مرة في out of n, the first time A happens ولا second time. Order is not important. It doesn't matter for me where the k times out of n A happens. ما تفرق. أهم شيء A occurred k times out of n. So it's a combination, number of combinations. N choose k. Multiplied by the probability of A to happen repeated كم مرة؟ k times. So it's p to the power k. So this is equal to n choose k multiplied by probability of a to the power k multiplied by 1 minus probability of a. كم مرة اللي يحصل عكس ال a؟ How many times شباب؟ n minus k. So out of the n, k times happen, k times a happens, and because of that, the probability of a to the power k, and n minus k, the opposite of a happens, which has a probability of 1 minus a to the power n minus k. So here a occurs k times k out of n times, while here a complement occurs the rest of the time n minus k times. And this one is number of ways k number of times k choose sorry, number of times, number of ways a can occur k times out of n. طبعا هنا زي ما قلنا order is not important. شباب أي سؤال؟ Any question? Are you with me?
دكتور معنا.
Yes, with you.
Yes.
طيب،
Yes,
ممتاز.
دكتور.
طبعا this Bernoulli trials it has many examples زي ما قلنا مثلا winning or losing, passing or failing, 0 or 1 في الباينري communication, hitting or missing if you are sending missiles مثلا, if in the radar systems there is target or no target. So it has so many applications in engineering, whether electrical engineering or others. Let's have one example here. We are firing a carrier with torpedoes. Okay, the probability of hit is 0.4. Okay, أنا عندي كذا قاذفة ترسل torpedoes. A torpedo, the probability of hitting a target is 0.4. It will sink if 2 or more hits is received. And we are firing 3 torpedoes. So total here is 3. So the probability of A here, probability of hit equal 0.4. And we are firing 3 different torpedoes. So it's N equals 3. So the number of experiments here is 3 times. Now the probability, I can ask, what is the probability of hitting 2 times? It's the probability of hit multiplied, sorry, to the power 2. It's 0.4 in the first time I hit, and the probability that I hit another time is 0.4 also. And the probability that I miss one time is 1 minus 0.4. Multiplied by how many times out of the 3 times I fired, how many times out of 3 I can hit. 2, which is 3 choose 2. ما تفرق المرتين اللي أنا صبت فيهم أول ولا آخر من 3 ولا في الوسط، ما تفرق. أنا my question is what is the probability if I have 2 hits out of 3? It's 3 choose 2, 0.4 to the power 2, 1 minus 0.4 to the power 1. طيب شباب واضحة؟
Yes.
واضح يا دكتور واضح.
طيب الآن I will ask you a question and send me the answer on the private chat. What is the probability of missing target? So I hit 3 times and I missed. Send me over the private chat, please, your answer.
How many times do you want to miss?
أنا قلت لك I missed the target. أنا أرسلت 3 و I missed the target.
دكتور يعني can you repeat the question? I didn't
يا
understand.
شباب, the same question as here. My question is, what is the probability that I missed the target? في الثلاث مرات. It's the same setting, the same question, same probabilities. The only thing that I'm asking is, بدل ما قلنا 2 hits, I missed the 3 of them. واضحة؟ يلا أعطونا. شباب, I only received very few.
دكتور few minutes بس.
Few minutes. باقي دقيقة ترى في الكلاس. يلا كثير. أسرع يا شباب. طيب.
Doctor, can you give us the answer?
And I don't have the answer. لكن I will solve it with you الآن. طيب, what is the
Yes.
probability of missing? أول شيء, it's basically how many times I missed. إحنا كم مرة سوينا experiment؟ 3 صح؟ 3 times.
3 times.
0.6.
So we missed in the 3 times. We missed in the 3 times, right? So if I missed in the 3 times, معناها إيش؟ It's 3 choose 0 or 3 choose 0 خلينا نقول. I wasn't able in 0 times to do it. Multiplied by 0.4 to the power كم مرة أنا أصبت الهدف؟
0.
Zero.
Excellent. Multiplied by 1 minus 0.4 to the power
power 3
3 لأن 3 مرات I lost, which is 0.6 to the power 3. عاد ما أدري كم يطلع هذا. الشباب اللي
0.2.
حسبوها.
0.216.
طيب.
I understand the question wrongly in my head. I solved it as that just calculated a third missed shot. حسبت على انه فقط واحده المس على نفس الاكزامبل، على نفس انه ثنتين جبتها وواحده غلط.
It's okay. أنا زي ما قلت لكم يعني الأنسرز ما أدقق فيها كثير. أهم شيء يكونوا موجودين معي وتشاركوا. لكن هي لما يقول missing a target out of 3 معناها هي 3 مرات and you missed. طيب ممتاز. أي سؤال شباب؟ Class is over. Any question? Those of you who would like to leave, you are free to leave. اللي عندهم أسئلة you can
جزاك الله
feel
خير.
free. وياكم إن شاء الله.